While most of the world's eyes are on NASA's James Webb and Hubble telescopes, a very different kind of alert comes out of China. The 500-meter Aperture Spherical telescope, known as FAST, the largest single-dish radio observatory on Earth, logs a burst. Not from a pulsar, not from a quasar, but from the interstellar visitor now haunting headlines everywhere, 3I Atlas. The signal is faint but structured. Analysts describe it as a millisecond spike of energy, the kind usually associated with fast radio bursts. But this one isn't quite like the others. It repeats. Sub-pulses rise and fall in a rhythm, as though echoing the steady 4-hour thermal heartbeat that NASA's James Webb Space Telescope had already reported pulsing from inside the object's core. Two independent instruments, measuring in different wavelengths, now point to the same unnerving possibility. 3I Atlas is not behaving like any comet ever recorded. From the moment of its discovery on July 1, 2025, astronomers knew something was unusual about this object. Detected first by the Atlas survey in Chile, it was racing into the solar system at over 150,000 miles per hour, too fast to be bound by the sun's gravity. That made it the third confirmed interstellar visitor in history, after Oumuamua in 2017 and comet Borisov in 2019. But even compared to those, 3I Atlas refuses to fit the mold. Photometric estimates suggest a nucleus nearly 10 kilometers across, yet the brightness is steady, almost mechanical in its consistency. Comets normally tumble and sputter, outgassing in chaotic bursts as ice turns to vapor under sunlight, but Atlas glows like a beacon, as though something inside is regulating its output. Then Webb spotted it. A thermal pulse, repeating every 4 hours, unwavering for weeks. Not random venting, not chaotic cracks, but a rhythm. As one planetary scientist put it, nature rarely keeps time so precisely. If the heartbeat was the first crack in the story, the mass was the second. Reports, including one covered by Wion, suggested the bulk of 3I Atlas could exceed 33 billion tons. That makes it far heavier than typical comets, which are fragile rubble piles prone to fragmenting. For an object this massive to also display sharp, unpredictable orbital deviations strains the physics of comet dynamics to the breaking point. NASA's models tried to explain the drift as outgassing, but the fit was uneasy. Residuals, the discrepancies between prediction and observation, persisted, as JPL quietly admitted in its logs. And then right when the deviation was most pronounced, NASA's live feed cut to black. Amateur astronomers confirmed the blackout wasn't local. Independent mirrors preserved the drop. 031712 UTC frame perfect across the globe. The coincidence was too sharp to ignore. The deviation and the blackout arrived in the same instant. If it was just outgassing, why did the record go dark? Into this atmosphere of doubt and speculation comes a new piece of evidence from halfway around the world. FAST in Guizhou province is uniquely equipped to pick up faint whispers from deep space. Its immense dish spans half a kilometer, sensitive enough to catch pulsars in distant galaxies and hunt for the faint signatures of alien technology. In early September, Chinese astronomers focusing on 3I Atlas detected a sharp radio burst. At first, it looked like the kind of fast radio burst that has puzzled scientists for years, a single pulse of high-energy radiation lasting only milliseconds. But this was not a one-off. The burst had internal substructure, repeating like a code. And its spacing matched almost exactly the thermal rhythm Webb had already recorded. When observatories in Xinjiang and Yunnan confirmed the same pattern, the odds of error shrank further. Interference from satellites, aircraft, or local radio sources was ruled out. The signal was coming from the direction of 3I Atlas. The cautious answer is plasma. Exotic chemistry within 3I Atlas, dominated not by water ice but by carbon dioxide and trace volatiles, could in principle generate electromagnetic oscillations when buffeted by the solar wind. In this model, the comet acts less like a transmitter and more like a tuning fork. Streams of charged particles from the sun strike layered ices, triggering electrical discharges that flicker in ways our instruments interpret as pulses. If so, the signal would be natural but exotic, a laboratory of plasma physics unfolding on a scale too vast to reproduce on Earth. Nature has a way of imitating order. Regularity does not always require intent. but the anomalies begin to stack. The thermal heartbeat, detected weeks earlier, already revealed a core glowing and fading with metronomic precision. Now, the radio burst emerges, synchronized in rhythm though expressed through a different medium. Heat and signal, light and sound, two voices humming in tandem. If this is not coincidence, then what we are witnessing is not random venting or chaotic cracking. It is coordination, energy cycling in deliberate intervals, a rhythm sustained across multiple wavelengths. Some astrophysicists have proposed cautious middle ground explanations. Perhaps the interior of 3I Atlas contains crystalline structures, exotic ices or minerals deposited under conditions never seen in our solar system. As the object spins, these lattices could expand and contract in cycles, squeezing out bursts of gas and radio noise, while simultaneously releasing heat. A strange but natural metronome tuned by alien chemistry rather than alien design. Yet even here, doubts linger. Why would such cycles be so precise? Why would the timing match across heat and radio bands? No comet observed by Rosetta, by Hubble, by countless ground-based surveys has ever behaved this way. And in the gaps between data releases, speculation sharpens. What if the coordination is not geological, but technological? Some whisper of engineered systems buried deep within the nucleus, a beacon or probe that awakens only once it crosses into the domain of a new star. A transmission meant not for us in particular, but for whoever might be listening, a calling card left adrift in the dark.
It remains speculation. No peer-reviewed paper has yet claimed intent, and no responsible scientist would rush to do so. But speculation thrives because the facts are stark. Two independent observatories, one peering in infrared, the other listening in radio, separated by oceans and governments, have logged repeating patterns from the same interstellar object. Not noise, not a one-off flare, but structured cycles across different bands of the spectrum. No comet in the archives has ever performed such a duet. And until the mystery is resolved, the possibility lingers, heavy and undeniable, that 3I Atlas is something more than ice and rock adrift. If the burst is real, and not an artifact, then China holds the first detection of what could be called an interstellar transmission, or at the very least, the first unambiguous anomaly that carries the fingerprint of something engineered. That fact alone would be enough to rewrite history. For decades, SETI searches across the globe have turned up only silence, the faint hiss of stars and galaxies, but no structured signal that could be traced to intelligence. If FAST's detection survives scrutiny, China would be the first nation to break that silence. The prestige would be immeasurable. But prestige may only be the beginning. Whispers within the Chinese Academy of Sciences suggest that behind closed doors, debates are already unfolding about how to respond. FAST was designed not just as an astronomical tool, but as a flagship of China's growing scientific ambition, a national project meant to rival Arecibo and give Beijing a direct role in the search for extraterrestrial intelligence. Now it may have delivered something no other observatory has. The question that follows is both technical and political. Do they sit quietly on the data and wait for others to confirm, or do they take bold action before the rest of the world can catch up? China has the tools to do more than watch. Its Long March rockets have already proven they can carry payloads into deep space. The Tianwen-1 mission placed an orbiter and a rover on Mars, and Tianwen-2 is preparing to conduct a sample return from a near-Earth asteroid. In terms of hardware, experience, and organizational drive, China has entered the tier once occupied by only the United States and the Soviet Union. A mission to intercept 3I Atlas before its slingshots pass the sun would be unprecedented, but not beyond the realm of possibility. The window is narrow, the object's perihelion comes in late October, but the incentives are enormous. If Atlas is merely an exotic comet, China would still capture the first close-range data on an interstellar body in history. If it is more than a comet, if its pulse and its burst implies structure, regulation, or even intent, then the first nation to approach it would secure not just scientific fame, but a claim on the future itself.
The puzzle deepens when we look at how data is being handled. NASA and ESA have already restricted public access to telescope feeds, citing planetary security as their reason. Yet to many outside observers, this does not feel like protection, it feels like containment. The blackout during NASA's own live feed in July has already eroded public trust, and each unexplained data gap only fuels speculation. China, for its part, has said nothing officially about FAST's detection. Not a press release, not a confirmation, not even a denial. Yet within the global astronomical community, the leaks are spreading. Emails, whispers, and second-hand confirmations hint that something extraordinary was seen, something that cannot be brushed aside as instrument noise. And so the question grows sharper. It is no longer only about what 3i Atlas is. It is about who gets to decide what humanity knows about it. There is a haunting symmetry to this moment. In the past, comets were seen as omens. The broom stars of ancient Chinese chronicles were interpreted as warnings of dynastic collapse or impending war. Medieval Europe stitched their fiery trails into tapestries as harbingers of invasion or death. Civilizations projected meaning onto every unexpected visitor from the sky. Today, the symbols have changed, but the unease is the same. Instead of fire in the heavens, we have unexplained blackouts. Instead of astrologers guarding secrets, we have classified data streams. And instead of priests interpreting portents, we have radio astronomers parsing bursts that may or may not come from intelligence. The omen has not vanished, it has only transformed. If the Chinese detection stands, it adds to a list of anomalies already too long to ignore. A thermal heartbeat pulsing with machine-like precision every 4 hours. An orbital deviation that coincided with a global feed blackout. A mass estimate exceeding 33 billion tons, so heavy it strains every known model of cometary structure. Chemistry dominated by carbon dioxide rather than water, a ratio never recorded in any comet before. And now a repeating radio burst, logged by the most powerful radio telescope on Earth, backed by independent verification. Each piece, taken alone, could be rationalized. Thermal pulses might be an exotic form of outgassing. Orbital deviations could be modeled with complex jets. A massive nucleus might be unusual but not impossible. Carbon dioxide-dominated chemistry could be the quirk of formation in another system. And even radio bursts might be natural, born of plasma physics interacting with solar wind. But together, these facts resist coincidence. Each anomaly amplifies the others until the object itself stands not as a curiosity, but as a challenge to everything we thought we knew about interstellar debris. Even mainstream voices are beginning to shift. Outlets like Space.com have already begun publishing theories that interstellar objects may seed planetary systems, carrying organic compounds across the void and kickstarting chemistry on young worlds. That is the cautious view. 3i Atlas as a courier of life, a messenger of panspermia. But late at night, on forums, in private Zoom calls, in whispered conversations between researchers who no longer trust official channels, another possibility is entertained. What if some interstellar objects are not accidents of formation, but artifacts of intent? What if they are probes, sent across light years, silent until triggered by proximity to another star? If so, then the burst detected by FAST may not be an accident of plasma or gas. It may be a handshake, a signal that the object has noticed us, just as we have noticed it. For now, the official record remains fragmentary. China has not released the raw data from FAST. NASA maintains that the deviations are still within the limits of cometary outgassing, and no peer-reviewed paper has confirmed a signal. But in the shadows, discussions continue. Should humanity attempt contact? Should we prepare an interception? Or should we simply observe and hope this object drifts past without incident? What is clear is that something extraordinary is unfolding. 3i Atlas is not behaving like any comet on record. It pulses, it shifts, it bursts. And now China may be preparing to respond. The world watches, waiting for clarity that may never come. Perhaps 3i Atlas will shatter like a comet, leaving nothing but dust. Perhaps it will continue past, silent and enigmatic. Or perhaps it will do something no natural object has ever done, something that forces us to rewrite not just astronomy textbooks, but the story of our place in the cosmos. Until then, the question lingers, like static in the night sky. What did China really hear when their great radio dish turned toward 3i Atlas? And what will they do about it?